sketch and label a figure for this problem. Confirm and support your result algebraically, and or using numerical methods. So, Phantom's Revenge, I think it's the second hill that's actually higher.
Yeah.
But it does go like below ground level because it kind of dips in that ravine. So this is kind of similar to that. But the first hill is 90 feet high. It drops to a low point of 20 feet below ground level. And it takes 210 feet horizontally for that to happen. So we're going to see if we can sketch a graph for part A. So it says find the sinusoidal model, which is another words of saying find the sine or cosine equation, for the height as a function of the horizontal distance from the top of the hill. That is, another way of saying it, the height with respect to the distance x is equal to a times the cosine of bx plus c. So we're going to have to kind of remember what all that information means. We can sketch a graph to help us find that information so that we can come up with an equation. So the graph starts where?
0.
At 0, and the height at 0 is 90 feet. So that's going to be our first point, up at 90 feet. So we're just starting now technically up, like the ride doesn't start at the top of the hill, but that's kind of what we're gauging it to get that nice curve. So thinking of that hill and as it's going down. It drops to a low point of 20 feet. So my highest point is 90. The lowest point would be 20. It's negative because you're going below ground level. And that happens, the lowest point happens at 210 feet horizontally. So right here, let's say 210 feet, we would have a point for the lowest value. So if you like, just picture that roller coaster, you're at the top, it's dropping to 200, or negative 20 feet, distance 210 feet. So we want to see if we can try and find an equation, bless you, that has the A, the B, and the D. We're ignoring the phase shift because the graph is starting at 0, so we don't have a phase shift to worry about. Does anybody remember what any of those letters represent or how we can find them? Sean?
A is the amplitude.
Yeah, so A is the amplitude, which means from the middle of the graph, how high are you going to the top, or from the middle of the graph, how far below are you going? What else, Sean?
I know D is the phase shift.
Not the phase shift.
It's
You're close though. Instead of shifting it left and right.
Horizontal.
Yeah, it's the vertical shift. So that part we call the sinusoidal axis. So it's the vertical shift. So that's the D. The B helps us find the period. So that's what the B value does. So let's talk about the sinusoidal axis first. The sinusoidal axis is the horizontal or the vertical shift from 0, or in other words, it's the middle of the graph. So where would the middle be between 90 and negative 20? Jake? 35. How'd you get that?
I added the two together, so 90 minus 20 is 70 and divided 2.
Okay, so he said he combined those together. 90 plus a negative 20 divided by 2, and you get 35. So the middle of the graph, halfway in between, that's what the sinusoidal axis is. Sean said the amplitude was A, so now looking at that value, the distance from 35 up to 90, 35 down to negative 20 better be the same, or Jacob didn't calculate right. So Sean, that distance from 35 to 90 or 35 to negative 20 is? Like, what's the distance between 35 and 90? 55?
Yeah.
Yeah? Okay. So that A value is 55. The last thing we need is the B value. B affects the period. And usually we say b is equal to what? How do you find b?
The period?
Yeah, but how do we find, like, how is that involved in the period? Greg?
Sorry, you find when it starts and ends. So
Yeah. So usually the period is 2 pi over b. So the period is when it starts and ends. Well, how much do we have of the graph right now? Half. So instead of using 2 pi, if we have half the graph, we would just use pi. So usually it's 2 pi over b, but we only have half the graph, so let's just say it's pi over b. So the period is from where it starts to ends. Well, half the period is still where it starts to where it's ending. So from the max to the min is the period of cosine. So Gray, that distance is 210. So 210 equals pi over b. So Gray, b is
Pi over 210.
pi over 210. Questions getting that information? So we're going to use that so that we can write an equation in h of x form. So amplitude 55, the distance from the middle to the top, middle to the bottom. The cosine of the angle pi over 210. And then the d value is plus 35. So that would have been how we calculated or created an equation back in chapter 4, section 5. But then we would have pretty much stopped. We didn't do much else with that equation. Maybe we plugged in a number for x. So the other two problems underneath, the questions underneath, want us to find the horizontal distance from the top of the hill to the point where the track reaches the ground. And then I think the third question wants us to find the horizontal distance, or after the front of the car falls a vertical height of 50 feet, what's the horizontal distance it has traveled? So now we're trying to find x, whereas in chapter 4, when we were doing these problems, we knew x, we plugged in x and we found y. We can solve equations now, and since we can solve equations, isolating a cosine graph or a sine graph function, we can solve for the variable x. So if we want to find the horizontal distance from the top of the hill to the point where the track reaches the ground, what would you plug in for the height? 0, yeah, because we're at the ground level is 0. So we're going to use this equation and plug in 0. So the height of the ground is 0, so we'll plug in the 0 value. And now we need to solve it. And to solve it, you're isolating the cosine. So we're trying to get cosine by itself. So Emerson, what would you do to get cosine by itself?
You would start by subtracting 35 to the other side.
So subtract 35, divide by 55. So it's just a pi. And Emerson, what would that reduce to? Yeah. So negative 7 over 11. And then we have the cosine of, I keep writing 2, pi over 210. So the goal is to get the function by itself. We now have the cosine by itself. So we took 35 to the left, divided by 55, reduce, keep it exact, don't give me a decimal there. The more times you round, the less exact the answer is. So now our goal is to find x. How do you get x if it's not on the unit circle? Jessica?
Use the inverse of cosine.
Yeah. So we're going to take the inverse of cosine of that negative 7 over 11. You're going to have to plug that in your calculator because we actually want a numerical value. So in your calculator, We have a pi, so we're dealing with radians. Make sure your calculator's in radians. So second cosine, -7/11. How about, like, I don't know, 3 decimal places? What'd you get, Emily?
2.261.
2.261. Questions so far? So this says find the horizontal distance from the top of the hill to where the point, where the track reaches the ground. So this guy here isn't the answer, because that would only be 2 feet. What do you have to do with that to find your answer? Jacob?
What would pi over 210x equal then?
Exactly. So this is what the piece right here, the part after cosine, is equal to. If I didn't have pi over 10 in front of it, then x would equal that. But because we have that value in front of the x variable, that value affects whatever you get when you plug it in your calculator. So in order to get rid of pi over 210, we multiply it by 210 over pi. And then we have the x by itself. What did you get, Jacob?
151.137.
137 or 67?
37.
37. So at approximately 151 feet, the car would be at ground level. And if you look at your graph, that's the area that we're talking about, where it's touching the ground. Questions? So the second question says, after the front of the car falls a vertical height of 50 feet, what is the horizontal distance it has traveled? So similar, except instead of it reaching the ground, it's falling a vertical height of 50 feet. What do you do with that vertical height of 50 feet? So it's falling 50 feet. Emily?
You subtract it from 90
Why would you subtract it from 90?
because it's fallen 50 feet from the original 90.
And how far is it then above the ground?
40.
Yeah. So the height represents the distance that the car is above the ground. So you can't plug 50 into the equation because then you're saying the car is 50 feet above the ground. Well, it isn't 50 feet, it's falling from the original 90 feet. So it's 40 feet above the ground. That would be the height of the car. And then doing exactly the same thing, we have 55 cosine pi over 210 x and then plus 35. So see if you can solve this to figure out how far the car has traveled horizontally. So now that we have an equation, we can solve the equation, we can find horizontal distance instead of always just relying on getting the vertical distance, the y value, which is what we focused on in the last chapter. So whatever you get in the calculator when you find x, or you find the angle, make sure you're setting that equal to pi over 210. Anybody have a solution to what you have?
98.931 feet.
I think this number is like 1.475 1.78, 1.48? Any questions with that? So if you look in your notes packet on page 25, there are 2 questions on page 25 that are both modeling problems, and you're asked to pretty much think about it in the same way. So you're going to make a graph. Using the graph, you'll create an equation. And then there's always going to be a question that it'll ask after you create the equation. But just to get you kind of a little head start on this first one, suppose one day 315 million people in the United States climbed up on tables. And we all jumped off at the same time, which how would that actually happen? Who knows, maybe it can with technology now. The resulting shock as we all hit the Earth's surface will start the entire Earth vibrating in such a way that its surface first moves down from its normal position and then moves up an equal distance above the normal position. The displacement y of the surface is a sinusoidal function of time with a period of about 54 minutes. Assume the amplitude is 50 meters. So they give us a lot of information here. So for part A, that's where I would make a graph so that you can kind of answer part A's question.
I'd just like to say, I read a book about this where the whole world did it, not just the US, and nothing happened.
Nothing happened. Well, that's kind
No,
of
that was a Vsauce video.
Yeah.
Yes.
It's a Vsauce video.
Nothing would happen.
So we're gonna just hope that maybe something happens because Emerson's book was wrong. So it's starting at the normal position, so it's gonna start at 0. And then it's moving down first. And then it's going to go back at normal, and then it's gonna move an equal distance up, and then it would return to normal. So this graph is a sine graph instead of being a cosine graph. It says that takes 54 minutes, so here should be the 54 value. The amplitude is 50, so the max is up at 50, the min is down at negative 50. Your goal will be to find when the maximum occurs for that first question. So remember, everything is cut in fourths. So halfway, you should then be able to cut it in half, get that location where the minimum is occurring when the maximum is occurring. Everything is equally sectioned off. The other part of your homework is the second to last page, and it's just 4 questions. You can't do the whole page because we haven't learned the other formulas yet to do questions 3, 4, and 5. So the first 2 questions are equations of multiple angles. The second 2 questions are equations that you'll have to use identities for to help you solve. So that would be a review of this section. Tomorrow we will kind of just practice some problems. You'll have an assignment from the book that will be collected and graded on Friday. And then Friday we're going to start the next section. There are 2 left that deal with trig formulas. And I'll give you a sheet that has all of the formulas on it on Friday. Questions? Answers were sent through Remind last period, so the solutions to both worksheets are sent through Remind.